So what this is part of a two-part project known as the initiative of the two-part project is to be able to grow anything, anywhere. So that includes growing cactus in Mars, growing tea in the desert, really to be able to plant anything in any single part of this whole universe, not just the world. So this is part of the model one. This is the first model. You should be able to grow anything, anywhere in this world. Right now we're restricting ourselves to the world only to planet Earth. So it can control any climatic condition. It can adapt itself, it can change itself to be at any climatic condition. So if you want a climate similar to that of Kericho, you could get it. So if you want that similar to a desert, you could get it. So realistically, you should be able to grow tea, cactus, anything inside here.
Depending on the location.
Yeah, depending on what you want. If something is used in a wet climate, yes, let's say and to do everything else. Obviously, it requires some human labor, assuming you have to do weeding at some times, maybe pruning, and then obviously harvesting. So this system currently requires human labor. In the future system, we anticipate it to be a box almost this size that can unfold to almost the size of this room. So it should be able to be fully automated, no human labor. Absolutely nothing. Everything is 100% automated. The water is being recycled from the system back into the system. Okay. That's our future will be. So for this one right now, it can control all the systems except the pH of the soil. Okay. That's when you find it a bit rather hard to. So you come this side now.
I think that's the most interesting.
So up here we have an external temperature sensor. It's a DHT2. So it measures the external temperature and the external humidity and then displays it. So the importance of measuring the external temperature and humidity is to be able to anticipate the internal temperature and internal humidity without changing it. So let's say you move the whole box, the whole system. Let's say you move it from like Kericho to now like another place, and you also want the system inside to be able to adapt easier and use less power. So it will also be able to change everything slightly according to external conditions. Because again, if it's too cold, it will delay that it's too cold on the inside instantly. It will take maybe like 30 minutes. And within those 30 minutes, you could lose a lot of temperature, but it takes quite some time to heat up the whole system to maybe even 29 degrees. It takes quite some time. Now heating up the system is heated up using a copper coil that runs on the inside of the soil.
Okay.
Yeah, so it runs, this is actually the copper coil, it runs in spirals throughout the whole soil. Yeah. That's ideally what heats up the soil. So all the readings from all the sensors are displayed here on this screen. So you can see the internal moisture content, the internal temperature, internal humidity. You can ideally see everything. We were supposed to use a much larger screen. We was something this big so that everybody can be able to see it easily. But right now that's what we have to work with. Yeah, just for demonstration purposes. So the internal humidity is being measured by this device. Okay. This device has the ability to detect the amount of water content in the soil. So that's what we're using to detect the internal moisture. Okay. See, when I remove this drop to 75%, but when I put it back, it might rise to maybe even 80. Yeah, see 80.6.
Wow.
Yeah. Now the internal temperature is controlled by this one. Let's see if you can find it. Yeah. This one. This is a DHT11 sensor.
And the moisture does not affect the circuit?
No. They are both waterproof. Okay. That one is waterproof. This one doesn't stay in the water.
Okay.
Okay. So this is a DHT11 sensor. It senses the internal temperature and the internal humidity to 0.5 or an error of 0.5 to 0.5 to an accuracy of 0.5. So it's very accurate. It's accurate enough for what we're doing right now. In the future, we anticipate to use a sensor that's almost 98% accurate. But then again, with an increase in accuracy, you get an increase in cost. So we're just trying something simple and not too expensive so that everybody can be able to see it. So now, we've been hearing, all along we've been hearing a beeping sound. Now I want to explain exactly what that beeping sound is. So this beeping sound, it's supposed to detect the quantity of water. It's supposed to detect if there's water inside the system or not. So when there's no water inside the system, like right now, these two are the same sensors. They're just interchangeable.
Okay.
Yeah. So when there's no water in the system, like right now, the system will beep and everything will run slowly. So if it's running water through the system, it will run water conservatively. It will do everything very slowly. So if it needs like maybe let's say 5 liters, it will try first 3 liters and see how far that goes. So everything will work very conservatively because the water right now is here. So now it's beeping to alert you that you need to come and refill it with water.
Okay.
Yeah. So that's what it's doing. You just need to refill the water. So maybe this whole thing could take like maybe a week to get depleted. Now, so what happens was if now I put some water on it, you know, it stopped depleting.
Feeding things fast.
Now that means that the water level is above this line here.
Okay.
So it knows it has enough water to do everything else. So now if you look at the readings, now it's showing readings that are changing a lot faster. And even this light is beeping a lot faster because now there's water to do everything that you needed to do. So it doesn't have to be that conservative.
Okay.
It has the ability it can run freely. It doesn't have to be constrained. Yeah. So now, when this is on, with the power from the power supply, we can activate these pumps to run water through the drip irrigation system. Wrong switch. Joking. Just clear up. You can hear the motors begin to spool up. They begin to run. Yeah. They begin to run. And so now, assuming that there is no water. Yeah, it's just beep again. Now, when there's no water, you can't draw out any water from the system.
Okay.
Now, what happens when, let's say, 1 day has passed and you still not refilled it, and the system needs water? Now, what will happen was it will go through an override system, so it will force the pumps to go on, regardless of how much water is remaining.
Okay.
So if you
And
click the
that is
button,
risky.
yeah, it's a bit risky, but again, we don't want to kill the plants.
Okay.
And where will the water come from if there's no water there?
The water level is here, so there's still some water.
Oh,
So it's forcing itself to go
force
through
it,
it.
yeah.
Yeah, it will force itself to go through to the reserves. The same way, if you don't eat, the body will first consume the fat, and it will force itself to start consuming the proteins in your body. Yeah. So if you click the button for long now, so maybe that's like maybe like after a whole day, it will force the pumps to go on and consume the little water that's remaining. Now once that's completely over, now you'd already been set like 100 alerts on your phone. You've been called by the system. Everything has happened.